This is our discussion video of our ME106 project. My name is Kalen Song.
My name is Ryan Borgman.
My name is Sadie Soares, and this is our project.
So the project is a remote control turret that operates as a platform for arm-wide platform rifles. Theoretically, it would allow a user to manipulate the weapon using a handheld remote that would control two axes of rotation and a trigger pull. The axes are controlled by a linear actuator and a servo motor, which is mounted underneath. The vertical axis is controlled by a linear actuator, and the servo motor controls the horizontal axis of rotation. The plunger solenoid would be hooked up to the trigger, which upon activation would pull every time a switch is pushed. The plunger solenoid and linear actuator are powered by the same 12-volt power source. The plunger solenoid is connected to a diode and an interface with a transistor. The linear actuator is connected to an L298N motor driver board that would allow it to dictate upward and downward motion. The servo is connected to a separate 6-volt power supply, and everything is controlled by a Arduino microcontroller, which takes inputs from a handheld remote.
Right. This design is made up of a wooden box recycled from a wine crate. It acts as an elevated base as well as a housing for electronics. The flange bolt bearing acts to secure the vertical shaft in place while allowing it to rotate. The upper mounting base is a flat wooden section with a rectangular cutout that allows the rifle's pistol grip and magazine well to be seated inside. The U-bolt secures it down. The two gears located underneath the box acts as a drivetrain between the vertical shaft and the servo motor. A challenge we faced was fabricating an adapter between one of the gears and the servo, since the output shaft diameter of the servo and the input shaft diameter of the gear were different.
For our project, we are utilizing Arduino Uno, since that is what our group is most familiar with. Initially, we wanted to use a Wii controller to control the project, but we ran into issues getting the two devices to communicate. The Wii controller board was having troubles communicating with the Arduino Uno when we're in the coding process. To avoid this problem, we opted to swap out the Wii dump truck for an Arduino-specific controller board. This board had a joystick and a button on it, which helped us synchronize the whole project. This simplified the coding process, as we're able to find open source examples on the Arduino database to help us code the entire thing. We split up our coding into three main subsections. The first subsection being the linear actuator, which we treated as a DC motor. The second subsection is being the servo, and the third being the plunger solenoid. Once we got all three of these codes working separately, we combined them as a whole, and after some troubleshooting, we were able to get the project to function as intended.
I was primarily responsible for our power interfacing, the troubleshooting, the parts sourcing and sizing, and the plunger solenoid code.
So some of the main tasks I took on were the linear actuator code, the controller design, and the code that relates to the controller, and also the drivetrain construction.
So I was in charge of the servo code, the design sketches, and I provided my woodshop experiences for the fabrication of the parts made on this. Overall, we learned the internal components of a linear actuator, since we had to disassemble it upon arrival. We learned how to interface different power sources with respective actuators. We expanded our knowledge on coding and the capabilities of the Arduino.